Okay, so transformations of functions, this is what we're going to do. So we're going to take a function, should make this a capital A, I guess. All right, put a little times there. So we're going to do some transformations of functions. Now, this is kind of an important idea because, I don't know, it depends, I guess, on how much more mathematics you're going to take, but this whole idea of transforming functions comes up in different types of graphs of them, and if you understand it, it makes it easy for you to just go right straight across all types of functions. So, for example, on Monday, we talked about, let's take a look at this one, for instance, okay, the absolute value function, all right, and that I said, so there are families of functions, and in this case, this could be thought of as the parent function. Sometimes they use that word, okay, a parent, and then when you start manipulating it, then that becomes sort of like a child of that function. Okay, so this would be like the main one, and then as soon as I take and put one of these parameters on it, then that changes it, the graph of it, and therefore becomes some like a child kind of thing. That's kind of what the whole idea is about. So what we're going to do is take this parent, which is an absolute value function, so it looks like this, okay, and we're going to manipulate it. So what we want to know is, what does A, B, C, leave some room by the way, and D do the graph. So make sure you leave some room here so you can write, okay, what A, B, C, and D do to the graph. All right, and to do that, we're going to do some sliders in Desmos. We'll do that and let you investigate that for a little bit, okay, and then we'll come back and look at some other functions. So back to this guy, and I'll show you how to set that up. All right, let me put this in projector mode so you can see things well. Right. Y equals, I don't know if we've done much with sliders, but like I was doing some stuff yesterday with one of my classes with sliders, and they were having a great time with it. So here's what we're going to do. We're going to go A, so I'm just going to put A, okay, and then I'm going to put that absolute value, which I believe is underneath functions and miscellaneous. Am I right? There it is. It's ABS. They call it ABS. Okay. Then we're going to put a B. Okay. Then I'm going to put a parentheses X minus. Then I'm going to put a C. And then we're going to click way past all those parentheses and put a plus D. Now when you do that, it asks you if you want to add all these sliders, okay? And we're going to say yes to all of them. So this is what it's going to look like, all right? So there's our absolute value graph. I'm going to play with it just a little tiny bit so it looks kind of like the parent. And you can see it. There it is. So this is the parent, right? We would say that is our y equals absolute value of x graph. So what I want to know is what happens if I change this a value to different things. Okay, so see, we're going to change the a value. All right, I want to know what happens. And then I want you to change the b value and the c value and the d value. All right, and tell me what happens. Okay, so this should take you about 5 minutes to investigate this, right? Now, if you want to, you can click this and it will play it, all right? And you could be like my high school students and play them all at the same time and go, wow, that's really cool, Miss Barry. Oh, yeah, that's really cool. But you can do it however you want, all right? So you're on the clock. You have 5 minutes. Let's see if we can figure out what A, B, C, D do to the graph. Might not even take 5 minutes. Moves on the y-axis. Okay, good. So we'd say that's a translation vertically. Mathematically, that's what we would say. Okay, if you're so if it's a back to this thing here, if we have absolute value of x minus 3, which way is it going to move it, positively or negatively? This time's going down, right? And if we have the absolute value of x plus 2, which way is that going? Which way? Up. Okay. So that one's not an issue. It's still moving d units. It's just that you don't have to worry about any positive or negative flipping stuff there. All right. So these are probably the bigger translation or transformations that you're going to have to deal with, is A, C, and D. But there is a B. It's just really hard to see what that does. Can anybody say what that does? Yeah. What do you mean?
Well, because it only, once you get to 0, it flattens out. So maybe thinking that it's 0 slope.
So once it gets to 0, well, that's because, let's look at that. So if we put a 0 in for B here, that's going to zero out everything inside that function, correct? Okay. Any other ideas on what B does? Good idea, though. It depends on A.
Stretch it positively, it won't go below where the origin is. I guess I don't understand very well.
Well, that's like I said.
If you make A negative, it won't go past the origin line. 0 instead of 0, like positive.
Okay, let's keep A at a number. Right? Let's say A is 1, just to simplify everything. Keeping A at 1, what does B do? Moving it around. Leave A alone. Don't touch A. Yeah?
You times the x by 2. X for each portion.
So what would that? So that's a good idea. Let's think about that then. So okay. So let's look at it from a table point of view, because they kind of do that. So if you take the absolute value of negative 2, what's that going to be? If you take the absolute value of, now if we put negative 2 in here for x, and we multiply that by 2, then that becomes what number?
4.
Negative 4, which becomes 4. Good. Okay. And then negative 1 here is just going to be, and then the absolute value of 2x would be, and here, and here, and here, and this is going to be, and this is going to be 2, and this would be. So what's happening from these numbers to these numbers? They're doubling, okay? All right, so when they're doubling, so let's see. Do this by hand. Here we are. Negative 2. It was 2. I'm going to draw this in this orange here. I'll put this in orange. So 2, 2, 1, 1, 0, 0, 1, 1, 2, 2. But when I put this in purple, see, I'm going to get 2, 4, 1, 2, 0, 1, 2, and 2, 4. So I get this graph versus this graph. So what does it look like it's doing? Stretching, huh? It looks like the same as A, right? Okay, but it's not. It's not. So, to show you better about what it's doing, I want to show you this kind of a graph, all right? So we're going to take that ABS out of there, and we're going to type SIN. So SIN is a sine graph, right? That's what this looks like. You don't really need to really worry about why it looks like this, okay? Because you'll learn this in, I think, 112. But anyway, the cool thing about this is we got a nice wave here, okay? And if I leave A1 and C0 and D0, excuse me, this is what this looks like. But watch what happens when I change the B. So which way is it changing this? Stretching it which way? Yeah, so actually, all right, let me go back to making this 1 and showing you this. So A stretches, we said, up and down, right, vertically, okay? But B stretches horizontally. And that's why you don't see it with the absolute value, because they're the same. It doesn't matter whether you put the 2 for A or the 2 for B, you're going to get the same thing. But here, it's a little easier to see that we have a stretch horizontally. Okay. All right, so that is what B does. And it's pretty hard to see it. In most cases, it's hard to see what B does, but it is a stretch in the horizontal. All right? So there's our transformations right there. Okay, and these work for any function. So let's do some non-decimal stuff here for a second. I want to come down to here. I don't want to go too fast, so if I am, just say, hey, wait. Let's say I have something that looks like this, okay? I'll tell you this is a square root function. Well, we'll just call it f of x. Okay, so here's a possible question I could see asking you in a week or so. Sketch that for me. What will that look like? All right, and I'm not giving you an equation. All right, I'm just going to give you a graph. I want to say, I want you to tell me what that's going to look like, or I want you to just kind of sketch it. Okay, so let's analyze this. What is this going to do? A vertical stretch. And what is this going to do? Okay, how much? Which direction? Okay, so that means that I should take this, this, and if I graph that, I'm going to move back 1, and then I want to stretch it, right? Boom, like that. Okay, so I move it back 1, and I stretch it. If it asks you to say, hey, verbalize what's happening there, we would probably say, well, we have a vertical stretch by 2 translate, or you could say move or translation, whatever you want to say, translation -1, or you could just say 1 to the left. All right, whatever you want to say. It does. If you have to verbalize it, then you can verbalize it using vertical stretch by 2, translation -1, or to the 1 left. All right, it doesn't matter to me which way you say it. All right. Okay. Cool. So let's try same thing. Let's say we have this. All right, and I say, well, this is f of x here. Ooh, let me change it to a different color so that we're contrasting it with the axis. All right. And so here's what I want. I want to see negative f of x minus 2 plus 3. Okay? Craziness. All right. We have no idea what that function looks like. It's just a v with tails. All right? No idea. So, verbally, what's happening to this function? What's going to happen to it? Reflected over x-axis. Good. What else? To the right. 2. Good. And up 3. All right. So, the question is, though, kind of is, what order would I do that in? Because it's a little bit, I mean, I understand that I'm going to bring it back, or excuse me, I'm going to move it to 2. Maybe this is 2 right here, so that's going to be my new point. I'll put it in blue here. Maybe that's going to be my new point right there for the x, if I just went x minus 2, all right? But then would I add 3 and reflect it, or would I reflect it and add 3? That's what we need to know. What would we do? So let's look at that from a table point of view. All right, here's my f of x here. So let's see. If I had a 5 here, right? The first thing I would do is subtract 2 from it, correct? Okay. That would give me 3. Then what would I do to it? Make it negative, and then we would add 3. So, yeah, basically, huh? Yeah. So, I get the 2 part. That's going to come first. Okay, what came second? And then, so when I do this, all right, here I am. I've already shifted it 2 units. What would I do next? I'm going to reflect it. So it's going to look something like this. And then what would we do after we reflect it? Exactly. So really, you're going to bring it up 3 spaces. I don't know where 3 is, but I do know it's going to look something like that. Okay? Wow, that's kind of crazy looking. Okay? Can I do what? Wow, that's crazy looking. No. You want the, yeah, sure. So here's what we did first. Okay, so we subtracted 2 first, correct? Okay. I just made up 5. We subtracted 2, right? Then we're going to apply the negative. Is it Jess? What's your name? What was your name? Jesse, okay. So Jesse says, then we're going to follow PEMDAS, right? So we're going to apply the negative. So I flipped it, okay, and then I shoved it up 3. All right? Because I don't know, I mean, I know to subtract 2 first. That kind of makes sense to me. But then I'm not sure, well, do I make it negative or do I add 3 and then flip it? Because if I add 3 and then flip it, am I going to get the same graph? So if I take this up here to 3 and then I flip it, where is it going to end up? Down here someplace, huh? Okay? So it's not necessarily going to be the same thing. So we kind of got to be careful. So let's try another one. Same idea. We'll use the same v here. All right, so let's try this. F of x minus 3 plus 1. Okay, so now let's just simply do this part. All right, so now we're going to go x minus 3 plus 1. So what am I going to do first? So we're going to move it over 3. I don't know where 3 is. I'm going to guess right there. And then what? We're going to move it up 1. No reflection. Okay. So you can do transformations and not even know what the function is. I mean, it doesn't really, that's the whole thing about it. These are actually pretty complicated questions because you don't know what the function is. Yeah?
So why there's no reflection with that one?
Why was the other one reflected? The first one right here? This one here that we did? This one?
Yeah.
Why is it reflected? Is that what you're asking me? Because of that negative in front, right? That's going to reflect it.
And then we shift the opposite of the, like we did -3, so we went to the right.
Because it's x minus c, so
Oh, we're treating it as the last.
so c is the 3, because it's x minus c, so it's 3 units that way.
But it's not absolute value, right? So.
Well, I don't know if that's absolute value, it's just a b.
Oh,
With
okay, I see
tails.
what I mean, all right.
Okay. We don't know what it is. I never told you. Okay.
But we're treating it as.
Right. I never told you what it was. Okay. So same thing here, here. Okay. Let's go. Kind of running the colors here. F. Here we'll go like this. Let's go -1/2 f of x. Let's do a plus this time. Plus 2 minus 3. Okay? How about this one then? Notice I didn't put any b's in there, right? Because it's really only ones that really show up with b's are those sine waves. You know, otherwise it just becomes a little bit more difficult. I can show you one with a b, but it's not very easy. All right. So what are we going to do first with this? Parentheses, so we're going to shift it 2 units which way? Left. Okay, I don't know where that is. I'm just going to take guess, say right here. Then what? We got to reflect it. Which axis? X-axis. What else? What is the 1/2 going to do to it? Well, negative reflects it. So let's see what you wrote down. You told me that when A is between 0 and 1, you get a compression. That's what you told me. So we shifted it over 2. Now what?
Bring it in.
Bring it in? Is that a compression? Or is it a... So if we stretch this, if I stretch this like this, okay? So if I stretch it, is it stretch this way, or is it stretch this way?
So it looks like A, depending if it's negative or positive, they'll do stretch in or stretch out. Right? So if it's negative, it looks like it's stretching in.
Okay, hold on. So if it's negative, what does it do?
It goes in.
Yes, it's going to reflect it over the x-axis. Okay. Regardless of what the value of the number is. If it's negative, it's going to go down this way now. If it's down, then it's going to go up. Okay, so we're reflecting it over the x-axis. Right? So don't let that mess you up. All right, but what's the 1/2 going to do? So we're going to get a stretch, or we're going to get a compress. Yes. So it's not going to bring it in. It's going to do what with it? It's going to compress, so it's going to widen it. Okay, so we got a reflection. We've shifted it over. So it's actually going to look a little bit wider. I kind of made it look quite a bit wider. All right, and then what's going to happen to it after we've done that? Down 3. So the real answer is down here someplace. All right, and it's okay to, if you want to draw it, a couple different times, that's okay. Just erase it or something. Just make sure you're using a pencil. All right, so it's going to look like that.
So the negative zero reflects it, and then the 1/2 that compresses it.
Mm-hmm.
Is it always going to compress no matter the number?
No. Okay, you have to go back up to what you wrote down here. You said that it compresses when the A value is between
0 and 1.
Right.
Yeah, but -1, that's what I'm confused.
It says right there, if it's less than 0, then
Okay.
Wasn't that -1/2 less than 0?
Well, okay, so you got to separate the negative out from that. So what does the negative do? What is a negative A going to hold?
Reflects it.
It's going to reflect it. So then you forget about the A. You focus in on the number. Okay, now hold it. It's 1/2. So what does 1/2 do? Well, it's going to make it. It's going to compress it, so it's going to make it.
So when is there a negative number? Because if it's a negative, wouldn't that make it a positive number?
It's not. A is between 0 and 1. It's not,
okay.
It's not saying that. So if it was a negative, so the negative is going to reflect it, right? And then just consider the A value. Don't worry about.
Okay.
Don't worry about. What was negative 1/2? No, the negative does, once you take care of that reflection, then you just focus in on the A value. Okay, what is the A value? So if it's -10, right, it's going to down here and it's going to pull like that, right?
It's going to go in because it's greater than
It's pulling.
1.
It's pulling on it. Okay, so it's stretching it out.
Right.
Right? That's what it's doing. Okay? What?
I guess the way that I was thinking about it was the compression is, so if it's like this, I was thinking of the compression to like push the 2 lines together. But you're saying it's flattening it to be 0. Compression is flattening it out.
Well, see, you got to kind of figure out. So what word would you use instead of compression then to make it sound like it's going down like this? How would you want to word that?
Oh, you're compressed it up.
Who said compression? Somebody said compression, right? Was that you, Jesse, said compression? So Jesse probably, when he thinks compression, he probably thinks pushing down. Okay? Okay, but maybe you think of it as something different.
Yeah.
All right. So it really doesn't matter to me whether you use the word compression or you use a different word that means the same thing. Okay? You got to make it work for you. What works for you is going to be different. What works for maybe everybody else in the room doesn't make any difference. Yeah. So a negative is just going to always reflect over the x-axis. Okay. It doesn't. It could be -100, which would be a huge stretch this way, but it's going to reflect it down on the bottom of the x-axis. It's always going to reflect it.
Negative.
Yeah. So you can. It doesn't matter what. See, that's why everybody, when they played around with the A value, they saw that it went like this, back and forth. Okay, and they saw that. So that was the first thing that came to mind. Was, well, it's stretching it. So it's either going like this, or it's stretching it right this way, out, kind of, right? But it took a little bit, and they found, well, wait a minute though, if we have a negative A, then it reflects it. Okay? Alright. So that's what's happening. So you don't really, once you see that negative, you think automatically, oh, it's reflected. Now I'll look at the A and see, is it reflected by stretching it this way, or is it reflecting it, or is it compressed? Okay. Once you get it reflected, then you look at the A. What's it doing there?
And then you made use of anything less than zero.
Yeah. Yeah. 0 to 1 is going to compress. And well, 1.5 is more compressed than 10. Does that make sense? Because 10 is going to really stretch it. 1.5 is just going to have a little bit stretch. Okay. So, like if we took your height and we stretched you 10 times, you'd be a lot taller than you would be if you were just 1.5 times smaller. If that makes sense. It's the same thing. And if I made it a negative 10, then you'd be upside down. Okay. All right. That's how that works. All right, go take your 5-minute break or so, and then I'll show you something maybe on Desmos here. We'll see how this, I'll look at it, think about it. Helps you with translations.
How does that last graph look?